Hey guys, today's another day of practicing choosing operations from word problems and then solving the problems using scientific notation. The math here, the computation, isn't actually the thing that's really tricky. It's figuring out what operation am I using. So that's the part we're really going to focus on together. Take a look. On your paper, please write example 1 and then none of those words. Pause if you need to. One New Orleans dump truck holds 3.0 times 10 to the 4th pounds of trash. And if another truck goes out the same day that holds 7.0 times 10 to the 6th pounds of trash, how many pounds of trash will they have hauled all together? All together is such a friendly term, and I'm going to talk to you about that in a second. Anytime I'm like, ooh, that was a lot of words, I'm not really sure what's going on here, I always reread the last sentence because that is usually where they ask you what, or tell you what you're finding. It says, how many pounds of trash will they have hauled all together? All together means I'm taking one amount of trash, another amount of trash, and putting them together. Anytime I take two things and put it together to find a total, that's adding. So I know the first truck was 3.0 times 10 to the 4th. The second truck was 7.0 times 10 to the 6th. At this point, you've learned two different ways to add numbers in scientific notation. One is to turn them into standard notation, regular numbers, and add them up. The other is to use your friend Lars. As an 8th grader, if you can move the decimals and add your exponents, that is way more efficient, but it's always a good idea to check your work by expanding the numbers out and doing it the normal way. So let's do this one both ways, and then for the rest of them, I'm just going to use Lars. On this one, whenever I add in scientific notation, the first thing I look at are my exponents. I have a 4 and a 6. They're different, so I can't add my coefficients until they're the same. I'm going to keep my greater exponent and then ask myself to get from 4 to 6, what would I do? Well, I would add 2. And if you remember, when we move our decimal left, we add to our exponent. I'm trying to add 2, so I need to move left 2 times. 1, 2. Drop off my decimal, fill in a 0. So my new problem is 0.030 times 10 to the 6th. Plus 7.0 times 10 to the 6th. Now that my exponents are the same, I can add up my coefficients. 7.0 plus 0.030. And remember, when we're adding and subtracting the decimals, we line up our decimal. 0 plus 0, 3 plus 0, bring the decimal straight down, and I get 7.030. But remember, I want it in scientific notation, so I just pull out times 10 to the 6th. I'm finished because this number has a coefficient that's between 1 and 10. That's how you solve it by moving the decimal. Let's solve it by actually expanding it out. Okay, 3.0 times 10 to the 4th plus 7.0 times 10 to the 6th. To expand these out, I pull out my coefficient, and then I move my decimal the same number of times as the exponent. 1, 2, 3, 4. I know that I'm trying to make this number greater than 3 because this exponent is positive. So this is 30,000 plus 7 times 10 to the 6th. Exponent's positive. I'm making this number greater. 1, 2, 3, 4, 5, 6. Perfect. That means I have 7 million plus 30,000. A big mistake that you guys made on your prove-its on Friday is that you were trying to either line up commas or you were filling in zeros when you didn't need to. Don't forget the basic rules of addition just because we're adding something new to it. This number is 30,000. This number is 7 million. When you're adding, you put the number with the longer number on top, the one with more digits. So this 7 million is going to go on top. and then 30,000 I line up over on the right. That actually makes sense because my invisible decimal is at the end of these numbers. So if you're getting confused about the decimal, put that invisible decimal in there and line them up. So I need to put 30,000 plus 7 million. And this is 7,030,000. If I turn this back into scientific notation, grab my invisible decimal and scoop it in 1, 2, 3, 4, 5, 6 times 7.03 times 10 to the 6th. Same answer either way. Let's do another one. The weight of Earth is approximately 5.66 times 10 to the 12 tons. If Miss Way traveled to a planet that weighed 8 times the weight of Earth, what would be the weight of that planet? Again, that was a lot of information. I'm going to reread the last sentence. If Miss Way traveled to a planet that weighed 8 times the weight of Earth, what would be the weight of that planet? Well, I know that Earth, and here I'm going to draw a little Earth for you. This is a good time in your notes to make sure that you have example 2. You do not need to draw this budget-looking Earth. But there you go. Woo, that looks so good. Okay, here's Earth, and I know that it weighs 5.66 times 10 to the 12 tons. Miss Way is traveling to a planet that's 8 times the size of this, which means if I wanted to know the weight of that planet, I would take Earth, I would take 8 of them, and then I would add them all up. So it'd be like this, plus this, plus this, plus this, etc. But rather than adding the same size thing over and over again, that's actually multiply. Anytime you add the same group, same size group, over and over and over again, that's multiply. So I can take this times 8. Last week we worked on what do you do if you have just a plain old whole number and then a number in scientific notation. Well, what I always do is I rewrite this as 8 times 10 to the 0. Because 10 to the power of 0 is 1, so this is the same as 8 times 1, which is the same as 8. So this has the same value as just plain old 8. Now let's review how we multiply. I really like parentheses because they help me stay organized for some reason. I don't know. If you don't like them, it's not that big a deal. I'm going to take 5.66 and multiply it by 8 because I'm multiplying out my coefficients. 5.66 times 8. Let's do it. 6 times 8, shut the gate, 48. 6 times 8, shut the gate, 48 plus 4, 52. Write down my 2, regroup my 5. 8 times 5 is 40, plus 5 is 45. I ignored my decimal up till this point, but now I need to bring it in 2 times because I have 2 numbers to the right of the decimal. So I have 45.28 as my new coefficient. I want my answer in scientific notation, so I rewrite it times 10. And then when I multiply with a common base, I add my exponents. 12 plus 0 is 12. So there we go. Something you should notice about this answer is that it is not quite correct. The reason is because my coefficient is greater than 10. To get this answer between 1 and 10, I scoop once to the left. Remember our dear friend Lars, when we scoop to the left, we add to our exponent. So I have 4.528 times 10 to the 13th. One more, then it's you. The distance from Mr. Perez's house to Mr. Heron's house is about 4.224 times 10 to the 4th feet. The distance from Miss Sedler's house to Mr. Heron's house is about 16,400 feet. About how much farther is it from Mr. Perez's house to Mr. Heron's house than it is from Miss Sedler's house to Mr. Heron's house? Again, that's a ton of words. Let's just focus on that last sentence. About how much farther is it from Mr. Perez's house to Mr. Heron's house than it is from Miss Sedler's house to Mr. Heron's house? In my mind, this is what I see. Here's Mr. Heron's little house. Let's put an H on it for Heron. We know that Mr. Perez's house here is 4.224 times 10 to the 4th feet away. Or, if I wanted to know how far just in regular feet, I can move my decimal 4 times. So Mr. Perez's house is 42,240 feet away. My house is 16,400 feet away, which is a lot closer. So my house goes right here. This is Sudler, 16,400. What I want to know is how much farther is it from here to here than it is from here to here. The way we figure that out is by finding a difference. We're subtracting. How much farther, how much greater, how much more, all of those are questions where we're taking a group away from another group. I'm taking away the distance from my house to Mr. Heron's house away from the distance from Mr. Perez's house to Mr. Heron's house. So my real problem is simply subtraction. I'm not going to work this out because I want to get you into practice, but if you want to work it out, go to town. Your turn.